All right, if you have not gotten the chance to watch the script video and follow along with that slideshow, I highly recommend you do that first before you watch this video, because it's going to talk about the process behind paired data. So with a matched pairs data, it's important to understand that this is it's a one sample. Okay, so even though you might have two sets of data, what we're doing is we're controlling for each pair. So each individual has two pairs of data, and you're getting the difference between each of those, and then you're comparing that one set of data. So we call that paired data, and the procedure is it's a one sample t interval, so it's going to be the same t interval as you've done for one sample, but we call the notation mu d, d for the difference. The parameter is, again, the true mean difference in each individual, whatever the context is of the problem. The conditions, same as one sample t interval or t-test. It's going to be random, 10%, and normal. And the formulas are the same as a one sample t interval. So again, those are the same interval or test statistic, and degree of freedom is n-1. But I, of course, encourage you to use the stat test menu for the t interval or the t-test. So just treat this as one sample, but for paired data, you subtract each pair, and then you take that one set of subtractions and use that as one sample. So it's important to kind of know to be able to distinguish between doing paired data versus two samples. So we have three videos here that I want to, or three problems that I want you to read through each problem and see if you can identify between it being whether you should use a two sample t procedure, whether interval or test, or you should use a paired t procedure. So let's read the problem and then pause for a second and see if you can identify if it's one of those two. Before exiting the water, scuba divers remove their fins. A maker of scuba equipment advertises a new style of fins that is supposed to be faster to remove. A consumer advocacy group suspects that the time to remove the new fins may be no different than the time required to move old fins on average. 20 experienced scuba divers are recruited to test the new fins. Each diver flips a coin to determine if they wear the new fin on the left foot and the old fin on the right foot, or vice versa. The time to remove each type of fin is recorded for every diver. So pause for a moment and think about which one you think this is. So the key here is that you're talking about a left foot and a right foot. This is one person, each testing out a fin on either foot, and those are randomized. Well, that is one sample. So because you're testing out and you're comparing the difference between the two fins, but you're using one sample from each person is controlled, that's going to be a paired t. So paired t-test or matched paired t-test. And then that parameter is going to be the mu of the d, so the difference from each one of those. Read the next one. To study the health of aquatic life, scientists gathered a random sample of 60 white piranha fish from a tributary in the Amazon River during 1 year. The average length of these fins was compared to a random sample of 82 white piranha from the same tributary a year ago. So pause to think about which one that would be here. Is it a two sample t or is it a paired t? Hopefully you decided it was a two sample. This one's a little bit easier because the sample sizes are different. You can't do a matched pairs when there's different sample sizes. So we can rule that out just from that alone. So we would say, since that's two samples, we'd say this is a two sample t, whether it's a test or interval is not important, but that's two sample t is what you're identifying. So that parameter would be the mu1 minus the mu2. So you get each individual means, standard deviations for each one, and then you put them in the two sample t. So that's that. And the last one. Can a wetsuit deter shark attacks? A researcher has designed a new wetsuit with color variations that are suspected to deter shark attacks. To test this idea, she fills 2 identical drums with bait and covers one in the standard black neoprene wetsuit and the other in the new suit. Over a period of 1 week, she selects 16 2-hour time periods and randomly assigns 8 of them to the drum in the black wetsuit. The other 8 are assigned to the drum with the new suit. During each time period, the appropriate drum is submerged in waters that sharks frequent, and the number of times a shark bites the drum is recorded. Pause to think which one that would be. While this one is a little bit trickier, if you guess 2 sample T, you're correct. You have, even though there are 16 2-hour periods, they're randomly assigned 8 of them to one drum and another 8 to another drum. And they're all of those different 16 2-hour periods, 16 totally different times. So since it's, you're not comparing one drum and 2 drums in the same time period, it's going to be 2 samples. So it is 2 sample T. And then, of course, that mean 1 minus mean 2 versus mean D. So that one's a little bit trickier, but that was that. Try the next, check your understanding. Researchers designed an experiment to study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took placebo capsules. The order in which subjects took caffeine and the placebo was randomized. At the end of the 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know whether being deprived of caffeine would lead to an increase in depression. The table below shows data on the subject's scores on the depression test. Higher scores show more symptoms of depression. We want to test this at a 5% significance level. So it's important. Obviously we're in the paired T video. So, we're going to use a T test, but it's important to recognize in this problem, because it's not going to tell you to use a paired T test, that each individual, the effects of the caffeine is going to be different between each individual. For starters, look at this one over here. This person actually increased or actually decreased on their depression scale from the placebo versus the caffeine. So obviously there are different factors on depression than just caffeine levels, but you got to be careful. Each person reacts differently to things. So when you're controlling for that, you have to use a paired T. So we don't get the mean of all of these. We get the difference of all of these, then get the mean and standard deviation to get that information. So this is going to be a test. And what I would suggest doing on this test is, get the difference first. So I'm doing, let me go through the process first. So this is a paired T test at the 5% significance level. And we define the mu D. So notice that I use that D subscript. And so what I'm saying is, it's the true mean difference in depression scores with and without caffeine. So we do with, I'm doing with minus without. You could do either way, but if I'm doing with minus without, then I'm going to do the top with minus without. So in that case here, you might want to take a moment to subtract these numbers here. So let's set our hypotheses. Your null hypotheses. Now, in a paired test, we want the null to be 0. Okay, we're seeing if there's a difference. So the null will be 0. Just like when you're doing 2 samples at 0. Now this one can be tricky, depending on which direction you subtract. The question says, I'll go back to it real quick. We want to test whether being deprived of caffeine would lead to an increase in depression, right? So one would think increase means greater than, and it really depends on how you subtract. In this problem, if I'm doing with minus without, now 5 minus 16, that's actually going to be a negative, right? Negative 11. 5 minus 23, negative 18, negative 1, negative 4, negative 6, negative 19. See how these are all negative? Negative 3, negative 13, negative 1. This one's positive 1. But because my values are being negative when I'm doing that subtraction, then I'm going to want that to be less than. So I'm going to say the mu difference is less than 0. Now, if I had done it depression minus caffeine, or placebo minus caffeine, I would have done greater because that depression scale is higher. Okay, so let's check our conditions. So we got, we got our random. The order was randomized, so they gave randomized who got what and when. The 10% condition doesn't really apply here because you're sampling with replacement. So each person is going to get the same treatment or going to get both treatments. So it's not really a big deal in this situation, but you're sampling with replacement, so it's not applicable. Now, as far as the approximately normal, you want to enter some data in the calculator to see what this graph looks like. So what you can do, you got a couple different options here. If you've done the difference already, you can enter those numbers in just like this. Oops. All right, so they should be entered in from these numbers here, just from the differences. Now you're going to have one set of data, but you want to look at the graph still from that one set of data. So go to second y equals, turn your plot on, and go over to your dot plot, your box plot. Turn that on. Make sure your L1. Then do a zoom 9. And we want to see if that that box plot is super skewed or has any outliers, which it doesn't. It's not going to, so there's no strong skew or outliers. And so you want to sketch just a general idea of what that box plot looks like. Now, hold on 1 second. Let's say you entered each individual list into your stat menu, thinking maybe it was 2 samples, but then you realized, wait, this is a pair t-test. Well, you can actually use your 2 lists to get you can put your difference from your list right into a different list. Here's how you do it. So if you got the first L1 and L2 list entered in there, you can go to the top of L3. So take a moment, pause the video, take a moment to enter those in. So you can do this with me, please. All right, hopefully you're ready. So at the top of L3, what you can do, since I did that first list minus this list, you can actually do second 1 minus second 2. That's going to take all your data in L1 and subtract to what's right of it in L2. And then if you press enter, these are your differences. So if you look at these numbers here, these negative numbers and that positive 1 at the end, these are the same numbers that I did just by subtracting. But now you have them all there. So what you can do is you can work with L3. So if I were to look at my box plot from L3, turn that on, and change my X list to second 3, do a zoom 9. Same thing, but you can see that we don't have to manually subtract all of those. Okay, so that's my approximately normal condition. Let's write it up. We want to do from your calculator, we want to run the t-test. It's going to be a, 1 sample t-test. So we're going to go to stat, edit, stat tests. And it's just going to be a t-test because we're doing, anytime you do a matched pairs, it's a 1 sample. And I have the data already entered in. Now, the null is going to be 0 for a matched pairs. I have it in L3, right? So if I do second 3, now that I have done my my subtraction and I input that L3, then I would do second 3. Now, if you are just kept what you had in L1, then you just keep it. If you did all the individual subtractions and put it in L1, you can use L1 as your list. And then we want to go less than, because this is we're doing with, minus, without, and they were negative, so we want that to be less than. So go down to calculate. And here's our data. We have t is negative 3.53, so we want to report that. Our p-value is 0.0027. Might as well write your mean and standard deviation, since we didn't get those before, with the sample size of n. So really, that's all you need. Now, as far as our summary, you just kind of compare it to your alpha. So in our summary, was our p-value of 0.0027 is less than 0.05, we reject. So if it's small, we reject. There is sufficient evidence to conclude that being deprived of caffeine leads to an increase in depression. And not for anything, you can also run an interval if you want. The results of the t interval, I'll run that for you guys too. T interval is going to be option 8. And if I use my data from L3 like I had, 95% is going to give me a interval between negative 12.01, negative 2.716. Those are consistent with our results because it's all below 0. So we have evidence of a decrease in an increase in depression, which is an overall increase in the negative numbers because we did with, minus, without. Okay, so after having watched the skew the script video in this video, hopefully you have a good understanding of the paired t-test and paired t interval, and you can work on the sapling assignment.